Distinguished ladies and gentlemen, I want us to look at the equations of tangents to a curve. And before we look at that is an example, I want us to take note of this, that we have the equation of a tangent to a curve, and we also have the equations of a curve. I want to say this, that the gradient of a tangent to a curve is the same as the gradient of the curve. The gradient of the curve is the same as the gradient of the tangent to the curve at the same point. Now, I want us to have a look at this question. That is question 1. The question is find the equation. Find the equation of that is the tangent. Find the equation of the tangent. Find the equation of the tangent to the curve. To the curve that is y equals to x raised to 3 plus 2x plus 1 at that is 1,4 at a point 1,4. Now this is the equation of the curve. This is the equation of the curve. Now I have said that the gradient of this curve is the same as the gradient of the tangent. Now let us recall that is the equation of parallel lines in Form 2. That two lines are parallel if they have the same gradient. Two lines that are parallel, they always have the same gradient. The same applies to this, that the equation of the tangent, or that is the gradient of the tangent, have that is the gradient of the tangent and the gradient of the curve, they are the same at a certain point. So we can say that if we find the gradient of the curve and we obtained that is a certain value, that gradient that we have obtained is just the same as the gradient of the tangent to that curve. Now let us have a look at this and let us try to solve this, or let us try to find the equation of the tangent to this curve. Now the gradient of this curve, is just that is dy over dx. That is, we shall find the gradient of this curve by differentiating it first. That is, if we differentiate the equation of this curve, that is x cubed plus 2x plus y. We are differentiating this function of y with respect to x. So we shall have, that is 3. We shall bring this 3 here so that we have x raised to 3. Then we less that power by 1. Then plus, if you differentiate this, the power of this x is 1. And therefore, if you bring that 1 here into 2x raised to 1, you less 1. That is, you less the power by 1. But if you differentiate a constant, because 1 is a constant, you get 0. Now, we have, that is 3x raised to 3 minus 1 is 2. Plus 1 times, this is 2x raised to 1 minus 1. 1 minus 1 is 0. X raised to 0 is 1. 1 times 2 is 2. Then 2 times 1 is 2. And therefore, this is the gradient function that we have. Now, we shall now consider the gradient of this curve at this point. That is at the point 1,4. At the point 1,4. So at the point 1,4, we shall only substitute the value of x, which is 1, so that we obtain the value of the gradient so that we obtain the value of the gradient. Now, if we substitute the value of x, which is the value of x is, that is 1. Therefore, if we substitute, we shall have, that is 3 into, that is 3x squared, that is 3 into 1 squared plus 2. So this one will be, that is 3, 1 squared is 1 times 3 is 3, then plus 2, we get 5. So this is the gradient of the curve at the point 1, 4. Now, the gradient of the curve at the point 1, 4 is the same as the gradient of the tangent to the curve at the same point, that is at 1, 4. Therefore, for us to find the equation of the tangent, we have to consider this point and the general points xy and this gradient, which is 5, because the gradient of the curve is 5 and the gradient of the tangent will also be 5. Therefore, we shall have, that is 1, 4, 1, 4, and the general points x, y, and the gradient 5, because we have said that this is the gradient of the curve, which is 5, and it's the same as the gradient of the tangent. Therefore, we shall have, that is 1, 4, and the general points xy, and the gradient 5. Now, in this case, we shall have change in y over change in x, that is change in y over change in x equals to 5. That you find the gradient of this and you equate it with this 5. The gradient of 1, 4 and x, y is change in y. This is y and this is y. This is y1, this is y2. So change in y over change in x equals to this 5, equals to this 5. Then we can say this is over 1. Then you can interchange. Therefore, we shall have, that is, we shall have, that is 1 we multiply with the numerator, that is 1 times that is y minus 4, it will just be y minus 4, equals to, we have 5 times the whole of this, that is 5 times x minus 1. And in this case, we have y minus 4 equals to 5 times x is 5x. Then 5 times -1 is -5. Therefore, we have y equals to, because this is -4, and if we take -4 to the other side, we shall have 5x minus 5, then plus 4. Because it is negative at this point, when it crosses this equal sign, it becomes positive. And therefore, the value of y is 5x minus 1. Now, that is the equation of the tangent to this curve. That is the equation of the tangent to this curve. That is the equation of the tangent to this curve.